Good morning to all of you. Thank you, Chairman. First of all, let me clarify that in the printout it is written BIS New Delhi. I am not from BIS. I am a former executive director from Power Grid, and having worked in the transmission and distribution system and smart grid for a long time, almost 41 years, and now I am a consultant advisor for the power T&D and smart grids. Well, I thought that let us share the success story of the control switching that we did in the EHV system. And if you look at the, what does control switching mean? Basically, it's the principle of, coordinating the instant of opening or closing of the circuit breaker with a specific target point on an associated voltage or current waveform is called control switching. Some people call it synchronized switching, and some people call it point-on-wave switching also. Now, in the earlier time, we used to have no control switching, and in the uncontrolled or random switching, it causes restrikes, reignitions during opening operations in the shunt reactors, high inrush currents during the closing operation in the power transformers and reactors. Now, if you look at what is basically control switching, additional capability added to the standard circuit breaker, operate the circuit breaker as a precise electrical movement and at particular target angle. And this is what is achieved through the control switching. So how control switching is helpful and why should we do it? First of all, it ensures improvement in the power network stability, the reliability of the service, supply to the customers, the power quality delivered to the customers, reductions of the electrical switching transients. It reduces equipment failures, comes down on the maintenance cost on the apparatus, capitalization, lower investments. Similarly, how does it improve the situation? Controls the exact movement of the circuit breaker is operated and eliminates the high voltage switching transients. And if you look at the overall picture, the circuit breaker becomes a smart device. Now it is like shooting the duck, from the ball, and if the duck is moving, the ball has to hit the duck at the right point. I'll just play it again for you. The waveform, basically it has to be the hit like this at the right moment when the breaker is operating. How does it work? Synchronization of the mechanical operation of the circuit breaker to the source voltage or the current. These 4 points, which are indicated as arrows on the graph here, they are the points where you have to hit and you have to measure. And those are the issues that we are talking about in the control switching. Now the basic architecture is using patented operating algorithm. The unit automatically adjusts circuit breaker operations according to the supply voltage, air temperature, pressure of the device, and mechanism, and so on. Now it not only controls the circuit breaker switching, it also monitors and reports circuit breaker performance problems and alarms. So it works as a online equipment which is giving you the feedback about the breakers. Now this is the basic architecture where you have the source, you have the load, you have the CT and PT, and the voltage and current sources are provided, and the substation battery and on-station RTUs are connected, and then you can give the command open, close, and program. It can be programmed. We have some experience sharing from the power transformer application from Power Grid. At 765 kV, 500 MVA transformer at Tamil Nadu substation. And you can see here, this control switching devices fits into the panel of the transformer or in the controls room very easily, and it can be retrofitted very easily. Now the power transformers, without using the control switching, it had the inrush current, and uncontrolled switching was causing close to about 3000 ampere. And you can see the waveform also, which is drooping down, and there are deviations in the waveform. Now when the control switching was applied on the transformer, the waveform has improved and the inrush current or the control switching inrush current has come down to 7.08 ampere, and definitely it has improved the situation. So let me tell you that the transformers are basically the major cost in the transmission equipment, and if the transformer is, fails, it's a major, direct loss to the utility, as well as, if the outage is a long outage, then it is going to cause system availability issues also. So we need to see that the primary equipments are properly protected, and control switching definitely helps in that. This is a shunt reactor closing. Also, we have observed that the shunt reactor closing is a very onerous duty on the breaker, and you can see here the physical movement of the contacts. This is you can see here the contact is moving, the arc is struck between the contacts, and then when it is fully closed, then the waveform is improving. So basically it's the operation in the closed form, then it is opening, and then it is the beginning. So the closing operation is done like this, and the system starts measuring at the time of strike of the arc, and when the contacts are coming closer to each other. In the fully closed position, the switching operation will be done. And not closing at the peak voltage, the voltage deviations will be observed, and we can see that the situation can improve if you put the control switching and the proper instant of breaker closing are decided. Now if you let us see the shunt reactor opening operation, you can see the breaker contacts opening now. When it is further opens, then there is a strike, there was a strike in the contact gap, and then it is fully opened, and the situation has now improved. So what we need to do is that for control switching, particularly for the shunt reactor opening and for the transformer, closing, switching on, we have to see that the control switching breakers are available. And this application was put on 50 MVR line reactor at 400 kV Maithan substation of power grid. And you can see that the equipment or the CSD, control switching device can very easily be put on the control panel as a retrofit. And you can see here the closing waveform was on control switching. Symmetrical current is 895 ampere before the, the application of the CSD, and then it came down to 87 ampere. So definitely the primary equipment is becoming, safer by adopting the control switching devices application. Now, as a waveform, we have open waveform with the reignition by the control switching, and so in most of the control switching activities, we are installing the control, these CSD devices or the control switching devices. Now, I would like to, of course, thank Mr. Kulkarni, who is sitting here, chairman of SCOPE, and Visimax, because I utilized some of their slides for making the point through. First of all, we should understand that it's a field-proven technology, and it is CV manufacturer agnostic solution, means it can fit into any solution, any CV, any make. Application to either new or existing circuit breakers. So even if you don't have control switching in your system right now, you can decide to do that. Power Grid has also done retrofitting in the last 3 years, and close to around 450 circuit breakers have been retrofitted. And now all the new circuit breakers in 765 kV, particularly for transformer switching and shunt reactor switchings, they are coming with the CSD retrofitted. And it's hardly any training required. And the achievements, as I mentioned, 450 control switching devices have been installed, and other customers also, like Alstom and Siemens and Cromptons, they are using the CSD of this make. And I have another small, presentation with respect to. Can you please come? 5, 6 in the top one. In fact, in my paper, if you go through the paper, the last two paras I have marked about the new development that has been done in, by the Scope company, and they have started a new company called Oxagrid, and with the office in the UK. And they are coming out with solutions which are very, targeted towards renewable integration. And these are very, very simple solutions. And I thought that I must definitely share this presentation, which Mr. Kulkarni has shared with all the grid operators at the national level, as well as at the regional level in southern region, and also I think western region. So the solution lies that as per our regulations, or as per our grid codes, all the generators need to be connected to the either SLDC or to the RLDC, depending upon where they are located and who are the owners. Now the question is that we do have a large network of optical fibers throughout India, but most of the power grid stations or EHV stations or power grid or some of the utilities are connected. We have around 55,000 circuit kilometers of optical fiber that is operative today. And still there are many nodes of our power system which are not connected on the optical fiber. Now, when the optical fiber connection is not there, how to bring the data? So the PLCC system is out now, so microwave system is out in India. So what you are left with is a simple, GPS solutions through 2G or 3G or 4G, depending upon those type of solutions. So what I want to tell you is that by these very cheap devices, you are able to integrate the system to the control centers very easily, and particularly from those installations which are RE farms, where either a large wind farm is there or a solar farm is there, where the connection is going on the EHV. See, it is not possible that on each and every wind farm or wind generator you are putting this. But on the RE farms, definitely it should be done. And this is a very, very cheap solution, which can be even commissioned in just 15 to 20 minutes for giving the data. Now the question is that how it is different from the, the PMUs that we are putting. I think for the information of the audience here, PowerGrid is putting the world's largest PMU-based single-phase project, VAMS, and we are installing around total 1,700, but in the first phase around 1,200 PMUs, and out of that around 1,000 PMUs have already been installed. Now all these PMUs are streaming data to the SLDCs or the RLDCs, and you can imagine the data size and data packets that are going. So nearly we have to talk about the big data, which the madam in the initial first session, she mentioned about big data management. So certainly big data management is very, very relevant. At the same time, the data which is available is able to give you a total picture about a good picture, means very granular picture of the power system. And it is like, having a sort of a, CT scan of the entire power system. We used to have only X-ray as per the SCADA EMS system. But now the PMU-based, system is going to give you a CT scan situation. We talked about frequency, management. We talked about voltage control. Also, we talked about the angular stability. I think yesterday these are the three pillars for maintaining the load balance in the system. And let me tell you that PMUs and such devices which are provided by these, integrators, particularly for RE integration, they are going to give you the correct picture at the control center to control each and every switching that is being done. Now the question is that how the control switching is relevant to the RE. I have explained that all the RE forms which are connected on the EHV will have lot of harmonics, lot of power quality issues coming to them, and we have to ensure that when they are being synchronized, they are synchronized at the right moment using the control switching devices, and at the same time we are ensuring the safety of the primary equipment. RE integration is important, but you have to see that all our transmission system, all our primary equipment are safe, and we are able to operate the entire EHV network in a very, very safe manner. So thank you very much for listening. Thank you.